Good afternoon and welcome everyone to session 7 of the Cybersecurity Awareness Series by ADL Connect, proudly brought by Asiata Digital Labs. Today, we are honored to have Sashika Suren, a seasoned expert with 14 years of experience in system security, SRD, and cybersecurity. Sashika holds a bachelor's degree in Information and Communication Technology from the University of Colombo School of Computing and a Master's of Science and Information Security from the same prestigious institute. Today's topic, Security Enhanced Linux. Today we aim to demystify SELinux and highlight its critical role in bolstering of cybersecurity defenses. Let's delve into the important topic with our expert speaker, Sashika Suren. Get ready for an enlightening session as we deepen our understanding of SELinux and its impact on cybersecurity. Over to you, Sashika.
Thank you, Jordan. Welcome back again to the this is as a DevSecOps team. This is the fourth sessions that we are doing. Previously we have done as a DevSecOps team, we have done certain enhanced knowledge sharing sessions about the cybersecurity related things. This today we will be going to discuss about the security enhanced Linux, or rather we call it as SELinux. This is basically like the major reasons that we have been selected. This one is we have been seeing sort of a knowledge gaps in the while dealing with the the SELinux environment in the Linux operating systems, and even you are a system engineer, DevOps engineer, and even the cybersecurity engineer. So there is a lot of knowledge gaps and the implementations deficiencies. So what we're trying to cover today is the understanding of the SELinux and why we need it, and let's do some practicals and with some hands-on experiences. So let's try to cover these things, guys. So the important thing that I want to highlight here is this is very much related to one of the Linux flavor called Red Hat Linux flavor, because we do have, you might deal with the different Linux flavors like Debian operating systems, Ubuntu, Debian OSs. This is not even OpenSUSE and SUSE Linux related, SUSE related operating systems. So this SELinux will be not impacted to those environments because it's not been implemented in those environments. If you are dealing with the Red Hat Enterprise Linux, CentOS, Rocky Linux, Fedora, this is the next level security module they have implemented into the Linux, the Red Hat environments. So today we will be basically highlight who are we. Obviously, you might know about us, but let's just give you some brief understanding. Permission models that we are going to do, the implementation of permission model. Let's understand the SELinux while we are going through the demonstration. So then the Boolean values. Of course, the demo will be run through while we are doing the session. So not at the end of the session. So obviously, it's a mix of demonstration plus the theoretical aspects. So we are actually DevSecOps team at ADL under the IoT and middle layer practice. So we will be delivering different types of cybersecurity services to the Asiata as well as other clients around the globe. So we will be providing the security supports varying from application security and then again software supply chain security, DevSecOps implementation and the consultations, post assessments, compromise assessment, and especially we have expert of teams in cloud security and the cost optimization on the cloud environment as well. So these are the different services which we are providing to the end customers. Anyway, like today, the main topic is going to be the discussion of the permissions. So if you look at the permission, we have mainly, if you look at the Red Hat environment, we have a three different permission models. And that three different permission models can be categorized into the two different categories. One is discretionary access control list, the other one is the mandatory access control list. When you say the discretionary access control list, this is basically the historic control file permission mechanism we use, like where we will be having user ownerships, group ownerships. We are going to assign the permissions based on the users, based on the groups, and the other user permissions. So it's direct, and we can revoke the permissions. We can add the permissions. We can do whatever we want. If you do have the privilege accesses, like if you are a root admin, root user in the Linux environment, of course you can do whatever you want. On the other hand, there is another one called mandatory access control list. Mandatory access control list, it will directly impacting the decisions basically taken by using the policies. So we have set the administrative policies. Those based on those policies, the mandatory access control list have been defined. So based on the policies, they will take the decisions, and they will either they will allow it or deny it. So it's a purely the policy-based decisions making process, where it's more granular and more fine-grained decision making process that they have implemented. So if you look at Linux environment, we do have a three different permission model, as I told you. One is basic file permissions, where we will be assigning the folders and files. Let me show you that one also. So these folders and files will have a single user ownership and the group ownership. Let's say, for example, if you go into the different environment, so you can run the ls-la command, and you can see that. So here user will be defined, student user is there, student group is there. So this is the user ownership and the group ownership. For each and every user, you have given the permissions. This is the user ownership permission, that is the student user having read write permission, student group having the read permissions, other users also having the read permissions. So likewise, this is just a basic file model, where we have a static file permission model defined. The users can access it. So this is the basic file permission. So basic file permission model will fall under the discretionary access control. And also you can set the access control. Like further, you can do a, let's say here we have only one user assigned and one group assigned. If you take, I'll take practical scenarios where we use those things. If you take file sharing environment, file servers. On the file servers, sometimes one single file or folder might need to have multiple user permissions and the multiple group permissions. In that case, the basic file permission will not be able to satisfy those requirements. So of course, you need to get with the ACS, what we call it as an access control list. So you can set the ACS by using the setFacal command. We are not going to discuss today because it's not the topic of the today. So basically, you can set the setFacal commands, and I'll just set it like this. SetFacal command to set the ACS. So just for your references, I'm going to set it. It's a ACL. So now we can add multiple users with the multiple permissions. So you can see if you run the getFacal command onto this particular file, you can see there is a extra user added. So that is also access control list, which is coming under the discretionary access control. Those two are basically the DAC solutions, and the SELinux. Security enhanced Linux is mainly focused on the mandatory access control. If you look at the mandatory access control, there are two major policies used. One is targeted, the other one is MLS. MLS, in the sense, it's called it as a multi-level security or multi-category security. If you, I'll tell you, like if you heard about the Clark Wilson model, Bella Padula, there are different type of security control modules like Bella Padula, Biba module. So those modules will be implemented with the MLS. Like if you want to implement BLBP, Bella Padula module, that is actually what they say is on top of the hierarchy, no read down, no write up. Likewise, they have a different type of policies. If you want to enable that sensitivity in your data set, you need to use the MLS. It's the sensitivity basically. Normally, these are very much used by the high sensitive environment like military organization, and then again, basically NASA, FBI. They will definitely using this MLS context to ensure that you have been given the fullest control, toughest security in your data sets. Because it's a huge sensitivity where we will be not providing into our environment. We mainly go with the targeted where they have been already defined processes with the targeted policies. It's maybe 100 plus processes, and those are protected. Everything else, like if there is no policy have been defined for any process, all those things are being set it as unconfined. Unconfined in the sense policy are not being enforced on those environments. So basically, let me show you where you can find those things. Basically, if you go to there are in the SELinux, you can have the configuration file under the etc SELinux config. In here, you will be seeing actually this we are going to discuss down the line. We are going to discuss this SELinux mode. But in the bottom, you can see SELinux type. There are two major types that we can use it, but we are not going to use. Only we are using the SELinux type is targeted. Because if you set to the MLS, multi-layer security, multi-level security, it's definitely going to be a huge concern for us because most of our data won't be able to access. Even we do have the root access in your environment. So since it's a very complex environment, we are not going to touch it. So we will be straight away dealing with the SELinux type is called targeted. So the configuration file basically will be laid under here, etc SELinux config. If you dealing with the RHEL operating systems, there will be an alternative file path as well under the sysconfig SELinux. So you don't want to worry about it. Both are, this is, you can see it's a soft link. etc sysconfig SELinux, they have been made a soft link with the actually the etc sysconfig SELinux config file have been configured as a soft link to this one. So wherever you change, it will reflect to the other. So you don't want to too much worry on that one. So when it comes to this SELinux environment, like obviously it's a mandatory access control mechanisms. We are using the targeted policy, whereas MLS is being ignored since the data criticality, based on our data criticality, we can survive with the targeted. So the next important thing, like I have discussed about three different permission model: basic file permission, access control list, and of course the SELinux. Do you have any idea like the precedence? Let's say, for example, if you have enabled all these three in your file and the folders on your file systems, which one executed first, which one executed last? What model has the most precedence and what model have the least precedence? Basically, it's pretty much straightforward. Nothing to worry. SELinux always wins the SELinux. SELinux definitely take over the precedence on the basic file permissions and the ACS. There are no doubt about it. Let's say if you have a file, like allowing the permissions and everything, but still you won't be able to access it. You won't be able to access it. The reason here is because of the SELinux. If you don't have the proper SELinux enforced in your environment, they cannot access it. So SELinux will take the first preference. So everywhere, like though you have allowed through the ACLs, though you have allowed through the basic file permissions. That doesn't make any sense. If there is any policy violations based on the SELinux configured policies, of course, the access will be denied. The second thing, ACLs. Then the second precedence goes to the ACL. If you don't have implement the SELinux, obviously then the second precedence or the preference will be goes to the ACLs over the and it will override the basic file permissions. That is how the ACL works. Finally, if you neither you have the SELinux nor the ACLs, basically it applies the basic file permissions. But if you have an environment where you have enabled all these three things in one particular single folder, don't worry. It'll first implement the SELinux. When you trying to access this one, they will first try, are you satisfying the SELinux policies? If it is okay, then you will be allowed. If you are not satisfying, you will be definitely denied. Though you have the rest of the permissions are being aligned, still they don't consider it. If it is passed, then they will check the ACLs. If the ACLs is allowed, then again it will pass. Doesn't matter the basic file permissions, then goes. If you don't have the ACL defined, then they will check the basic file permissions, then allow it. Because in one certain conditions, we can have a basic file, we can have ACLs, we can have SELinux. Everything can be have it in one single file or folder in Linux environment. That is possible. So the precedence will go in that way. SELinux prioritize, nothing else. And one of the important thing here is what you need to know is why we need to have the SELinux. SELinux, I'll tell you the comparison here. If you are using like you might have questions like if you are not using Red Hat environments, CentOS, Red Hat variations, like what is the mandatory access control model they have been implemented in the Debian and the SUSE Linux? Because we have seen like in enterprise environment there are implementations which is specially going in the SUSE Linux if you are dealing with SAP ERP systems, so they might basically dealing with the SUSE environment. So don't we have the Mac and mandatory access control for the Debian operating system or SUSE environments? Of course they do have. It's AppArmor. If you compare the SELinux and the AppArmor, SELinux is more complicated and more sophisticated, where it will provide more security features than the AppArmor. The reason why the AppArmor is not providing, AppArmor is a sort of an extended version of the ACLs. They have been taken leveraging the basics from the file permission model and created the AppArmor. Therefore, they don't support a lot of features that the policy you can't create your own policies. Let's say, for example, if you are seeing any policy violation in the SELinux environment, there is a flexibility that you can create the custom policies. So the policy flexibility is given, but in AppArmor, that is not like that. So they don't provide it. And even MLS, that what we have discussed earlier, MLS is being only enforced in the SELinux. AppArmor, since they have been leveraging the basic file permission and extending those features to provide the Mac, they don't have the MLS facility. That means you cannot implement Bella Padula or Baiba integrity model into those environment, basically Debian environment. So the SELinux provide those things. So likewise, there are different type of actually benefits over the AppArmor even. That's why the SELinux is being heavily used by the National Security Agency, previously called as a Department of Defense and the FBI. And I guess the NASA also, they will be utilizing those things because they are dealing with the highly critical, highly sensitive data. The sensitivity of those data is much important. And the important thing here is, and the defense in depth. SELinux, when you talked about the file system permissions, SELinux will be directly talking to the kernel level. So if you want to control your permission models through the kernel, so this is the best way to do that one. So which will provide you the in-depth security by integrating the kernel. So defense in depth is definitely supported in the SELinux environment. And one of the important things that you need to understand here is if you are dealing with the SELinux, you don't want to restart. You don't want, there are no daemon or services given in the SELinux environment. It's basically the SELinux, it's a kernel implementation. So you will be definitely using the kernel implementations. And I'll tell you one case study very like 2 to 3 years back, there was an incident happened to one of the web server. Actually, fortunately, they have run the web server on a SELinux enforced environment. Due to the one of the vulnerability exposed in that particular web server, web application, the attacker has planted the remote code execution into that environment. And fortunately, there was a script run on that environment, but like still, since they have been implemented the SELinux, there is a process isolations. When you create a Linux environment, SELinux enforced environment, all the processes will be running independently. They will have their own territories. Let's say, for example, just imagine if you see the states in India, you will be seeing a different type of states. Like I don't know, there are different states. So the different state maintain different lawsuits. Similarly, when you enforce the SELinux also, they will maintain for each and every service that you are running. Let's say you have a web server, you have a mail server, you have a DB server. So the mail server will run, will have the basically one territory. They will have one territory. So they do have their own laws. So no one, if anyone wants to access those, anyone wants to come to their gates, so they need to comply their laws. Basically, they need to have the necessary policies in place in modules. So otherwise, it's a totally isolated environment, totally isolated. So because of that, though you have been attacked through the Apache, that Apache user cannot access to any other environment, even the temporary directory. Because of that, they cannot actually implement any scripts on the temporary directories, and they actually failed on the attack. Still, the web server is compromised, but the attack surface that they can take in, it's a reduced. So we can reduce the attack surface by using this type of SELinux enforcement. So the isolation of processors. Of course, SELinux is just not protecting your files, but it will be supporting you to protect your network services. So all your network ports which are listening on your environment are being secured with the labels. So we are discussing the label concepts in the next slide as well. So you can integrate this SELinux with the IPS IDS environment. That is also possible. So it's obviously a compliance standard. So most of the CIS benchmark, one of the compliance check that they have been enforced is you need to enforce the SELinux on your Linux environment. So that is one of the compliance checks that they have been enforced. Likewise, there are a lot of features, a lot of benefits when you use the SELinux. Especially, you can reduce your attacking surfaces and minimize your threats onto your environment. Sorry, guys. So that's the benefit that you are getting with the SELinux when you are dealing with the SELinux environment. So let's look at how the SELinux works. Basically, by default, this is the default policy. By default, SELinux will block all the applications. That is the default policy. Then, based on the policy that you have given, based on the rule set that you have given, instructed, it will be allowing who has access to what type of resources. So that will be allowing. All these decisions made by the SELinux kernel modules will be cached on a component called access vector cache or AVC. AVC is one of the important things. Before they take any decisions based on the policies, they will look at, are there any cached environment on this particular policy enforcement. If it is there, it will directly block, or if it is not there, So they will consult the, there is another component called security server. They will consult the security server. So basically we have a subject. Actually in SELinux environment, they have defined two things, two components, subject and the object. Subject in the sense it can be a user, group, or process, because process can be accessed files and the folders. Like say for example Apache process. Apache process can be accessed file and a folder. So basically what you need to understand here is when you are going with this subject can be a user, group, or the process. Object can be the file, processes, folders, socket, memory locations, anything like that. So what basically SELinux policy says here is which subject can access what kind of objects. So that exactly defined here. To take those decisions, they have two things in here. One is actually security server. Security server in the sense the set of policies which is defined in the SELinux environment, and access vector cache, or rather we call it as AVC. AVC in the sense it's a decision storing environment to speed up your decision taking process. So this is what you need to understand. So each the security server, this can be definitely resides on the kernel, and the object manager and the AVC, it can be resides on both the kernel and the user space applications as well. And this security server also can be centralized. That means you can take the policies from the centralized locations as well. That is possible. That is one of the benefit against SELinux which gives to you, where the AppArmor does not provide that type of things. You can have a centralized remote policy server, and the policies can be obtained from those centralized policy servers as well. That is also possible. There are certain configurations which we need to do under the same manage configuration file. There is a configuration file called same manage conf. That where we can do the changes. So that is also possible in the SELinux environment. But let's see how this Linux is working. So I just want to highlight few things. If you look at here, just to give you some idea, when you run with any Linux command, if you want to get the SELinux, we call it as a context. We will be using capital Z. Let's say if you run the ps-ef capital Z, so you will be seeing the context, SELinux context of these processes. You can see these processes, right? Even if you run the ls-laz, you can see the context of the each and every files and the folders. So the first parameter will always tells you the user context. The second parameter will always tells you the role context. Third one is a type context. The fourth one is a security level, MLS, multi-level security. So when you do the troubleshooting, when you are dealing with this SELinux environment, when you want to do the troubleshooting, we are not always touching this one, because this is we leave as the default option. We are not going to touch. But basically S0 in the sense they will allowing all the sensitivity level from top to bottom. So there are no restriction on write down, write up. That is not there. So this is by default one. If you can see in processors also, you will be seeing it's a C0 to S0 to C0 to C1233 1023. So this is the sensitivity level allowed everything. So you can see its sensitivity level allowed everything. There are no Bell Padullo debug module has been implemented. So now, and the other thing here is user context. Of course, SELinux users are being mapped to the all the users in Linux environment. If you see the say manage user -L, I'll show you. Say manage login -L, login -L. These are the different type of SELinux users defined in your systems. You can see that they have assigned the different roles. Users are being defined here, and they have assigned the different roles. Whenever you create the users in Linux system, Linux users, they will be automatically mapped to one of these Linux users. By default, root user is mapped to the unconfined underscore u. Every other ones users also mapped to the unconfined underscore u. If you see the unconfined underscore u user have the set of roles, system role and the unconfined role. That means basically users are not restricted based on the SELinux. Let's say, for example, if you want to restrict the user by like issuing sudo commands, by issuing su commands, what you need to do is you can assign the users to this use underscore u group. That means it'll automatically, this use underscore u user cannot execute sudo commands, su commands. And even they cannot log in remotely to the while using SSH. Likewise, there are different roles that have been defined. So you can see these roles and the users are already predefined. Therefore, we will be not going to touch these things because we don't know what kind of definitions they have given to these roles and the users. Because of that, we are definitely not touching these two as well. When you are dealing with the SELinux, what we are touching, what we changing is the type context. When you change the type context, you can allow the accesses through the policies or deny the accesses through the policies. So that's where we do. We always try to change this one. We always try to change this one. So not user context, not role context, not definitely not the sensitivity, only the type context. How this SELinux is working, let me explain you. The next one is actually the enforcement working. Let me explain that one. Huh? So let's say we are going to start the Apache environment. Now I'll tell you, I'm going to start the Apache. So if I try to start the Apache, what I'm going to say is, I am going to say, now if you check the status of the HTTPD service, let's see here, it's loaded but inactive. Now, if I try to start this service, what they are running in the backend is, they will be running the basically, let me show you that one. They will be running basically user bin HTTPD, this one. So I think SBin HTTPD, SBin HTTPD. This particular executable file will be run when you say start. If you see this one, if you see this SBin HTTPD, this file contain HTTPD underscore exec underscore t file context. This is the file context, type context. What they are going to do is, if I look at the process here, HTTPD, whenever you running HTTPD underscore exec underscore t, this particular file, it will contain this particular file to the domain called HTTPD underscore t domain. This is your domain now. This is your domain. Like if you run in a SELinux disable environment, SELinux where you don't have the SELinux, so it does not have the boundary like that. So Apache user can access var www.html, they can access var temp folder, they can access temp folder, any global accessible folders and files can be accessed by this Apache user. That's the case. But when you run this one, they will run this particular fold, the executable, and they will create this, they will convert this HTTPD underscore exec underscore t to a domain called HTTPD underscore t domain. Now, this policy define what we can do and how we can do. This policy basically define, they can access, if anyone coming from this policy, httpd_t domain, they can access a content with having the policy call, with having the type context called httpd_sys_content_t. The httpd_t domain can access httpd_sys_content_t type of content. It also can access httpd_config_t type of file system as a configuration file. So this is the policy defined. This is the policy for any process. That is what it defines. So whenever they create the boundary, that boundary will define, okay, who can access what. That is exactly given here. So this says that httpd_t context can be able to access httpd_sys_content_t type of document roots, configuration files, content files, and http_config_t type of basically the configuration file. Apparently they have defined, they have a lot of other things as well. And the log folders, they can access the log folders like httpd_log_t. That is how they define the policy. Like, let's say now, just imagine if you are going to change the document root. Now just think about, like, I am going to change the document. When I create the mkdir command, look at this. Now the changing will happen, but what is the policy they have defined? The context is set to the default_t, where this policy does not allow to access with the context file called default_t. If you allow it, so it's going to be a security concern. So they won't be allowed to access this one. So if you want to allow to access this data folder by the Apache or httpd_t domain, what you need to do is, based on the type that you really require, like since this is a document root that we are going to set, so we need to change to the document root file system context. Yeah, you can see, you basically can see this one, httpd_sys_content_t. You can see this one. So we have to set it to here as well. So we definitely need to set the http_sys_content_t in here as well. To do that one, you can definitely deal with the there is a command called say manage f context. So like if you have certain doubt, with the Linux there is a lot of man pages, which is we will be heavily using for the troubleshooting purposes. You need to install this particular package, policy core util -devils. This is the package that you need to install. With this package, they will provide you all the man pages, and you need to build the man pages. So once you install this one, I'll show you that one for your preferences. You will be able to see this one. These man pages are pretty much important for us when we are dealing with like this SELinux, because it covers everything. It defines, okay, what kind of SELinux context that they can access it, what kind of things that we can do it. So say for example here now, then we have to run the say policy man page command to build those man pages, because once you install this one, it does not you won't be able to access through the man commands. If you run the man_SELinux, you don't see any man pages here. It's just only one default page. Other than that, you don't see anything. First, what you need to do is you need to build those things. You have to run the say policy man page -a command to build this one, to build it, and I'll be building these things, but it'll take some time just to show you. So anyway, that is how it's going to happen. So now you will be able to see, like you will understand that it'll definitely building up these man pages, but it'll take some time, sir. Let's see. 1 to 2 minutes will be within 1 to 2 minutes will be complete entire things. There will be 800 plus man pages. So now they are building up the man database. This man database is building on temporary folder. That is also totally fine. Nothing to worry. So you can see there are different type of man pages for like these are the services. These are the different type of services. Let's say for example, if you don't want to like you might see that there's a huge customization on this our environment. Because of that we want to change the SELinux. So as I told you, we have a 3 different SELinux mode. That is actually SELinux enforcing mode, SELinux permissive mode, SELinux disable mode. In enterprise environment, it is highly recommend not to set to the disable mode. The reason is if you set to the disable mode, it'll for a files and folders for the process that you are running will remove the labels. So it is not recommended to whenever you are going to deal with the SELinux, not recommended to set to the disable mode. Because if you do facing any kind of if you are facing any kind of issues with the SELinux mode, you can straight away set to the permissive mode. In the sense they are not enforcing the policies, but they will log the policy violation. That is for our purposes. It's a kind of a monitoring mode that they do. In the permissive mode, keep in mind that they are not enforcing any policy. They will run through the just as a monitoring mode. They will log the policy violation onto the var log log. That's it. Enforcing mode, obviously the policy is already enforced and they will be definitely block any kind of policy violations. So those are the 3 different policies which we can implement in here. So if you want to implement the 3 different policies, you will be seeing that just I'll take another session here. You will be seeing that in the configuration file. So that can be seen in the configuration file. So let's look at here. Now, if you see here, I'll just take in sysconfig SELinux. You can set the SELinux by default. It is enforcing. You can set to the permissive. There is a one command. Normally, when you do the changes in these environments, since this is a kernel implementation, you need to reboot the server in order to effect those changes. There are no services daemon to restart. Like in the live environment, we can't do those type of reboots as we require, because we need to get the downtime requests, and there are so many change requests that we have to run, so on and so forth. That because of that, they have given the command line tool, set enforce command, which is you can switch while you are running the machine. You can switch in between the SELinux permissive and then enforcing mode. When you say set enforce 0, it will be set to the enforcing mode. When you say set enforce 1, it will be set to the permissive mode. But keep in mind, if you forget to change the configuration file and by mistake if you restart it, it will take the by default configuration file changes will be taken to there. So even you can run the save status command for a detailed understanding, not the get enforce set command. So you can see it will give you the detailed understanding with the say enforce command, say status command. You can see the current mode, and then you can see the mod from config file. So normally when you do the reboot, it will take the mod from the config file, not the current mode that you have set it in the live environment. So keep in mind that one. So this is for the set enforce command has given to testing or try out any errors that is pertaining to the SELinux enforce environment. So that is one of the important thing. Even, and let's say for example, like as I told you, like if you are facing a lot of issues with one environment. Let's say you are dealing with the SELinux and you don't want to too much worry that you have been not doing any lot of customizations there. There are no customizations happen. So then you can survive with the same manage SELinux enforce environment. But let's say you have a web server and you have done a lot of customizations, let's say because of your application. In that case, what you can do is you don't want to set entire environment to the permissive. What you can do is you can set only a one particular domain to the enforcing. Let's say httpd_t. This domain only can be set to the enforce. Then rest of the other domain, rest of the other environment will run on the SELinux enforce mode, and this domain will only run on the permissive mode. So for this domain, they will not enforce any policies. It will only log the policy violation. So you can enforce, you can set the individual domains into the permissive mode if you require. This is the best way if you want to deal with the, like, if you want to set any kind of domain into the domain, in the sense we are referring here the domain in the sense I told you, like whenever you run any kind of executable, they will create a domain here. That domain, this is httpd_t domain. So you can convert only that particular domain name to the enforce permissive mode if you really require. That is also possible. There's the command say manage permissive -d httpd_t domain. So over any other domain, let's say if you're running a postfix or network manager, let's say network manager, we don't do like that, but just for your understanding. So let's say we can say manage permissive -d network manage_t. This domain can be permissive. So it'll take some times. So this will not support for the permissive. This domain not support for the permissive. There are cases like some domains might not say support for the permissive as well. Let's do the httpd_t. They will definitely support. These are there is, I think, there is issue, I guess, because otherwise it will be basically supported for this one. Let's say -l for to look at what are the domains that have been permissive. So anyway, that is possible. I think there is issues with this environment since this is a lab environment that we are using. But normally it should support nothing here in the permissive mode. Normally it should support for the permissive state. So you can be able to run through the permissive, because you can see there is in here also, it will directly give you the examples as well to set to the permissive mode. That is possible. That is possible. Like you can set the content into the permissive mode. I don't like, we can troubleshoot if you want, but with the limited time, I'm not going for the troubleshooting. Right. So that is how it's working. Now you can see if you look at the httpd_SELinux, you will be able to see all these things. So this is the SELinux security policy for the HTTPD process. So this particular man page define all the policy, the entire policy here. So you can see everything can be seen here, like who can access what. So you can see they have been set the policy to httpd_var_run_t. So set files with the http_var_run_t type if you want to store the httpd files under the run or var run directory. So likewise, you can see all these things one by one. If you want to have your read-write executions on your user directories through the Apache, you need to set this particular context. So likewise, there are different type of SELinux policies. You can see all these SELinux policies here. Define it. And if you want to, if your environment supporting for the read-write environment, like you have the read-write, you need to provide, like say for example, file uploads. In that case, that particular directory should have the read-write this particular context. Otherwise, they can't run the file upload as well. So you can see, of course, different permissions, policies have been given here. So if you want to, like say for example, if you want to set this one as a not, definitely they'll be not supporting for the default underscore t. What you need to do is you need to change this context. So there is a file for the command called manage fcontext command. Again, you don't really want to remember these things. You have the man pages and all those things to get these things done. So what you need to do is you need to set to the exact context. You can take it from the man page by reading those things, and then you just a matter of changing the type context. As I told you, we are not changing user context, role context. We are not changing level context, MLS. We just do only changes type context. Now when you set there, so it will be taking some times to change these things. Now if you run the restore cons minus RV options to the data, it will be changing the. Now if you see here, so you can see it has been now properly set the policy. Now you can, without any concerns, questions, you can use this directory as your document root in Apache. So this is how we troubleshoot it. Most of the time, if you've seen here, I'll quickly go through the best practices as well. Then I will just show you the demonstration, the Boolean values and the port. So basically, if you can see here, always these are the best thing that you need to survive with the SELinux. Always, if you install any kind of environment, deal with the default files and folders given in the particular process. Let's say Apache has the default folder var www.html as a document read, root, etc httpt as a Apache configuration file locations, and then again etc httpd var log directory as a log folder. If you stay with those default locations, you don't come across with any SELinux concerns. But when you go for a customized locations, then of course you are having issues with the SELinux. The second thing is, as I told you, don't disable SELinux. If you don't want, just set to the permissive. That'll work basically. And as I told you again, if you want to set a single domain to a SELinux permissive mode, that is possible. You can run it with the SELinux manage permissive command. That will do the work. And one thing also, I'll tell you one important thing. Don't move the content. In Linux environment, keep in mind, don't move content. Let me show you that one. If you move, let's say for example, if you move this particular file into the data directory, what will happen here is, just look at here. I'll show you that one. What will happen? It will move with the original folder's file context. The reason is, if you copy in SELinux environment, I'll copy this one. Just look at. I'll just copy it into the data directory. Now, just go. Let's see what has happened there. ls minus laz. So you can see move directory has file context from the source location, but the copy file will have the file context, SELinux file context from the parent directory, that is data. The reason is when you move it, when you move a file, it will move with the inode, index node. Basically, inode is maintaining the metadata of the files in Linux environment. For each and every file, let me show you that one. ls minus li will show you the inode numbers. For each and every file, they do have inodes. If you move it, they will move it moving inode as well. Inode, if you are moving inode in the sense original location metadata set, because SELinux label is one of the metadata in file and folder. Original location metadata will be moved to the destination location. That's what happened. That's why moving is not recommended. File moving is not recommended when you're dealing with the SELinux environment. When you're dealing with the SELinux environment, it will always you need to do the copy. When you copy it, what they're going to do is they are going to create a new inode with the parent folders metadata sets. This is they are inheriting parent folder metadata set as well. So you can see this is the new inode that they have been taken. So this is the best practices that you really need to look at when you are dealing with the SELinux. And there is two things that I want to show you and highlight you. With there is a concept called Booleans. Booleans, what they really do is it's a additional feature adding to the policies. It's a kind of a on and off. Let's say, for example, let me show you that one also. Let's say, for example, there are different type of Booleans. Say, for example, if you want to let's say when you're running a multi-tier environment, you have a web server here, and in a different network, you have a database server. If Apache wants to connect to the database server over the network, if you are running the Apache server in a SELinux enforce mode, of course, though you have managed everything in proper way, you can connect. You can't connect. The reason is there is a policy addition that we need to enable, that this one. HTTPD underscore can underscore connect and network underscore connect to 1. By default, this is 0. You have to set it to this one. You can use the set sable command. With this one, what they are going to do is you will be allow access to connect the Apache, allow Apache to connect with the remote database service. So there are certain policies that they have been set by default disable or enable. Most of the policies are being in the disable state, but some are in the enable state. See here, this one is by default enabled. If you want to allow HTTP to use built-in scripts like PHP, Python, Perl, then obviously this has to be enabled. By default, it is on. That feature is already added to the HTTPD underscore T domain. So likewise, this particular one, sorry guys, particular policies, there are a lot of policies. For the Apache, there are a lot of policies. If you want to enable the send mail access, mail sending facility, this has to be enabled by default. This has to be enabled by default, it is disabled. So likewise, there are a lot of things that you need to enable in the policies as well. This is what we call it as a Boolean values. Apart from that, I'll just again go through it. I told you like port also, the different ports also labeled. So I'll tell you for the HTTPD, they have been labeled certain set of ports, HTTP, they have labeled certain set of ports. That means this domain, that means they say HTTPD underscore T domain can access only the port with the label of HTTP underscore port underscore T. If you change it where it does not have here, let's say for example 80 is there, let's say 82 port. If you try to change the port into the 82, just look at this one, just a last thing that we are going to do. So let's say this is your 82 port. Now, if you change, let's say 82 not listening here. If you change and try to restart it, so it will giving you errors. The error here is, if you look at this one, it says permission denied, could not bind the address. This one, non-listening socket available. You can see even Apache cannot start. The reason is the port is not being labeled here, because basically the port is not being labeled. If you want, you can label the port. That is also possible. You can label if you running the unstandard ports, like non-standard port, like this is an unstandard port. So I'm just taking the commands from the man pages. I'm not remembering anything. Just straight away taking the man, using the man pages to get the command, because I cannot remember the commands. So you can see now, let's add the port to the whatever the port label. Port also label. That is also one of the important things. That's how they have been achieved the network security. Now, if you check here, you can see the port 82 also in here, right? Now, without any concerns, you will be able to use it. So if you do have any issues, concerns, normally journal CTL will provide you the error. Apart from that, you can refer to the var log audit log also, and grep for the AVC deny access. Let's grep for the AVC. So if you're seeing the AVC deny access, this is actually very much related to the this is not actually deny access. They very much related to the SELinux. So the logging will be there, and even if you want to have further troubleshooting, you can install. There is another tool which is not recommended, but if you want, you can install. There is another tool called Say Troubleshoot Server. Say Troubleshoot. This one can be also included if you want. Then they will adding another command called Say Alert. Say Alert. There is another command will be added here. Say Alert. So where you can use that one as well. But in production systems, since you can see for this particular command tool, there are a lot of packages that are going to added. Because of that, we are not adding here, but we can survive with whatever the log files that is retained in our environment, journal CTL, and the var log audit log. So that is also can be used to deal with it. So basically, this is the things that you need to understand in the SELinux. Of course, there are a lot of things that you have to get your hands dirty when you are dealing with the SELinux environment in order to understand this much better. So, gentlemen and ladies, if you do have any questions, you can raise. This is our email address. Like if you need any concerns, questions, you can reach to us at any time. So devsecops@atthelabs.com. So if you do have any questions, ladies and gentlemen, you can raise.
We would also like to extend our gratitude to Sashika for delivering such an insightful session. Undoubtedly, we've gained valuable insights into this dynamic field. And as Sashika mentioned, if the audience has any questions, you can either raise your hand, or it would be more convenient if you enter your questions in the chat box. So we will allocate a few minutes for everyone to share their inquiries.
Jordan seems, I think we are good, right? I don't see any questions.
Yes, it seems there is. So in that case, once again, before we conclude, we would like to give a heartfelt thank you to Sashika for generously sharing his expertise with us today. Your time and knowledge are truly appreciated by us all. And thank you to all the attendees for joining us for this session. We eagerly anticipate your participation in our upcoming ADL Connect series. So wishing everyone a wonderful day. And once again, thank you, Sashika and audience for joining us today.
Yeah, thank you very much. Thank you all for joining us the sessions. Thanks.